Hello everyone, today we're going to take a look at topic 3 of our Unit 5 Mastery Check, the trigonometric equations. So let's go ahead and get started with this review, and then of course you, just like last time, have 4 practice questions after that you can try that will kind of match up with these. So maybe work through the first one and then try the next one as you're going, that way you're kind of keeping up with it and getting to apply the skills you're learning yourself. All right, so first thing says we're going to solve for variable x on the given interval. And we can see that it's 3 tangent of x minus square root of 3 equals 0 with the interval negative infinity to infinity. So first thing is we know that this right here is a q that we are going to use our plus or minus pi k or 2 pi k depending on what we are working with. And in this case, since we're working with tangent, we know it's going to be plus or minus pi k. Remember, sine and cosine get plus or minus 2 pi k, but tangent just gets plus or minus pi k. So we're going to go ahead and solve this out and work this out. So the goal here then is to get the tangent by itself. So the first thing I'm going to do is I'm going to add square root of 3 to both sides. This cancels out, and I have 3 tangent of x equals the positive square root of 3. And then we'll divide both sides by 3 to cancel this out. Tangent of x equals, now, because the top number is under a square root and the bottom number is not, there's nothing I can do there. You can't actually do the 3 divided by 3. So it's just going to stay tangent of x equals the square root of 3 over 3. Which, when you look at your unit circle and think about that, there is a certain spot that would come up, but it is kind of tricky. At pi over 6, the coordinates are square root of 3 over 2 and 1/2. So if you were to take the y over the x right there, you would get 1 over the square root of 3, because we can ignore those denominators, which, if you were to rationalize that, that would come out to square root of 3 over 3. So we know that this is going to happen at pi over 6. So our first solution is when x equals pi over 6, and we're going to put plus or minus pi k. And we'll box that answer in. Now, if you're super confident with your understanding of tangent, you would know that we are done right here. But maybe you're not. Maybe you accidentally make a little mistake right here and you keep going. So let's look what that would look like. If you were to keep going here and you were to continue... Okay, if you were to continue here and you were to say, oh, I also recognize that tangent is positive in quadrant 3, you might also put 7 pi over 6 as an answer. The thing is, if you were to take pi over 6 and add 2 pi to it, sorry, not 2 pi, we don't add 2 pi, we add 1 pi to it, right? Because that's what our formula over here says. If you look right here, it says add pi k times. So we're going to add 1 pi to it, so this would become pi over 6 plus, to rewrite that in terms of sine, we'd multiply, sorry, in terms of a 6, we'd multiply the top and the bottom by 6, so we get 6 pi over 6. So 1 pi plus 6 pi would give you 7 pi over 6. So this already gives us this answer, so we don't need to put the extra answer in. So as long as you're confident with this, you just need to remember that tangent only gets one answer on the unit circle, so you don't do all that extra work. All right, for our level 2 question, we can see that this one has a cosine squared in it, but our interval is 0 to 2 pi, so we know that that's going to be a little bit easier. We don't have to worry about all the other stuff on there. So let's get our cosine by itself. First thing I'm going to do, subtract my 3 to both sides, cancel. And we get 4 cosine squared equals negative 3. And then we'll divide both sides by 4. And we get cosine squared equals negative 3 over 4. That's not going to work. What did I do? Because the problem is, if you square root this, you're going to get it doesn't work, right? You can't square root a negative number. I made a mistake. I screwed something up. Shocking, right? Shocking. Okay, let's do this. We're going to make a small change to this problem that you'll already have known about because I would have told you in class. Boop. Make that a minus. Let's try that with that being negative. So now we're going to add 3 to both sides. Cancel. 4 cosine squared of x equals 3. And then when you divide both sides by 4, you get cosine squared equals 3/4. So now it'll work. Now when we go to the step where we have to square root both sides, we can actually do that. Remember, when you square root both sides, a couple important things happen. 1, you have to get plus or minus for your answer. You have to include both the positives and the negatives, so don't leave that out because that's the easiest way to get these questions wrong. And then we just square root them separately. So you square root the top number. Can you square root 3? No. So you're going to leave it under the square root of 3. But the bottom number, can you square root 4? Yes, the square root of 4 is 2. So I'm going to put 2 on the bottom. So this overall becomes cosine of x equals plus or minus square root of 3 over 2. So we want all the square root of 3 over 2's regardless of if they're positive or if they're negative. So we're going to go through and pick all of those out for our answers. Now, again, because it's 0 to 2 pi for this interval, we don't have to put the plus or minus 2 pi k for this one. We just need the answers. So we know cosine is square root of 3 over 2 at pi over 6. We know that it would be negative square root of 3 over 2 in the second quadrant. So that would be 1 less on top, so 5 pi over 6, so the numerator is 1 less. And we know that it would also be negative in the third quadrant where the numerator is 1 bigger than the denominator, so we'll have 7 pi over 6. And last but not least, we've got in the fourth quadrant where the numerator is 1 less than double the denominator. So double the denominator is 12, 1 less is 11, so we've got 11 pi over 6. So you need to find all 4 of those answers for this to be correct. All right, coming down here onto level 3. This one says solve for the variable x, and they've given us a secant plus 1 and a tangent squared on the other side. Again, noting that it is negative infinity to infinity, so we are going to need to do plus or minus pi k or plus or minus 2 pi k, just depending on what solution we work with. This one could be a little bit tricky, but what I'm immediately picking up and recognizing is that I know that tangent squared and secant squared go together, right? These two have an identity together, especially this tangent squared, because we have our Pythagorean identities. And I'm going to write it right here. We knew that tangent squared plus 1 was always equal to secant squared. So because I know that identity, what I could do is I can start by taking this thing out right here and using that identity to replace it. So the left side is going to stay the same. Secant of x plus 1 definitely stays the same. But that right side, instead of putting tangent squared, we could move this 1 to the other side, which means it would become minus 1, and replace it as secant squared minus 1. And I'm going to use an x because we are working with x's, right? It was tangent squared of x, not theta. So I'm going to change it to an x. So now I've got things that are actually kind of the same, so it's a little bit easier. I think the best thing to do is to move everything from the left to the right because it would keep the secant squared positive. So we're going to subtract the secant of x, which doesn't have anything to go with, so we're just going to put it right there. Cancel. Subtract this 1, subtract this 1, and ultimately this cancels and we end up with secant squared of x minus secant of x, and then those two negative ones make negative 2. And I know the equal 0 is in the front, but I'm going to move it to the end. So now I can see that I've got a nice problem here that would actually... Sorry, hold on.
Grades are due by 9 a.m. They're due by 9 a.m. in EdC. Thank you guys so much. Appreciate it.
All right. So now I've got this problem that I can actually factor, so we're going to go ahead and do that. So secant of x will go first and first. I need two numbers that multiply to make negative 2, but add up to make the negative 1 here in the middle. So I know that's going to end up being negative 2 and positive 1, right? Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So we'll put secant minus 2, secant plus 1. And now, because this is multiplication to get to 0, I know that this is equal to 0 and this is equal to 0. We've got two separate questions we're going to solve now. So secant of x minus 2 equals 0. Secant of x plus 1 equals 0. All right, so here I'm going to add the 2 over, and I get secant of x equals positive 2. Now, I know that I can't solve for secants off the unit circle because we didn't memorize that. But I can change secant into the cosine as long as I change this into its reciprocal. So the reciprocal of 2, which is technically 2 over 1, is going to be 1 over 2. And now I could solve that. Over here, same thing, we're going to subtract 1. So I end up with negative 1 on the right. And again, change secant into its reciprocal cosine. Change 1 into its reciprocal, which is still negative 1. And now I could solve that a little bit better. So let's come up with our two answers. When would cosine be 1/2? We know that would happen at our over 3's, pi over 3's. I need it to be positive, so we are doing the entire unit circle, sorry, not even the entire unit circle. We're doing negative infinity to infinity, right? So we need to put, since it's cosine, we're going to put plus or minus 2 pi k. Remember, tangent's the pi k, sine and cosine get the 2 pi k. So we're going to put x equals, we know that this would happen at pi over 3 plus or minus 2 pi k. We also know cosine is positive in the fourth quadrant. So we know the other answer from this first part when it's 1/2 would be when we have 5 pi over 3.
Good morning, teachers.
Again, I'm sorry.
If you have not signed off for your certifications, please do so. Ms. Brito is next to the mailroom. Once again, teachers, if you have not signed off for your certifications, please do so next to the mailroom. Thank you.
Lots of announcements this morning. Okay, the last one is this one over here. Now we're working with this cosine of x equals -1. So in this one, we know that cosine of x only gives you -1 at one spot. Only one place can you get -1. So that was going to happen when we are at pi. So pi plus or minus 2 pi k. And so those are our three answers, making sure we put plus or minus 2 pi k on all of them because we're going negative infinity to infinity. All right, and on to this last one, everybody's favorite. We can see that right here, there is a 3 in front of the x, which means we know that we're going to have to triple our answers at the end of this problem. So let's try to keep it a little bit small up here. Let's not write super big. So I know that this should have an equals 0 right here. I don't know where that went. Okay, that equals 0. So we're going to subtract the square root of 3, so 2 sine. You know what? I'm just going to work it out, right? To keep space. We're going to subtract the square root of 3 and then divide by 2. I think most of us are pretty confident with doing that now, right? All right, so we know that on the interval of 0 to 2 pi, this happens in 2 spots. We know it's going to happen for sine, since that's the y value. We know it's going to happen at pi over 3's, but it's going to be negative, right? It's got to be negative square root of 3 over 2. So it wouldn't happen at pi over 3 because that's positive. Since sine is the y value, it's going to be negative in the third and the fourth quadrant. So we know that would be at 4 pi over 3 in the third quadrant because it's one bigger on top, and 5 pi over 3 because it's one less than double the denominator for the fourth quadrant. So there is our 2 places it normally comes up. Now we know that we're going to have to double these answers, right? We know that 3x is equal to 4 pi 3. And then we need to add 2 pi to that. So the way that we would write 2 pi over 3, we'd have to multiply the top and the bottom by 3. And we'd get, sorry, I pressed the wrong button. There we go. 6 pi over 3. And that's what I'm going to add and subtract to the top and the bottom. Not subtract, sorry. We're just going to add. So if I take 4 pi over 3 and I add 6 pi over 3 to it, we're going to get 10 pi over 3. And since we're doing 3x, we've got to do it a third time. So we're going to add 6 pi again. So we're going to get 16 pi over 3. And for our second set of answers, we said that it was 5 pi over 3. And again, add the 2 pi to the top. So we're going to add 6 pi over 3. So we get 11 pi over 3. And 17 pi over 3 when we add 6 pi to the top. And of course, the last step here is I want to make this 3 go away. So I'm going to multiply by 1/3. So everything gets multiplied by 1/3. So if you multiply all the top numbers by 1, they're going to stay the same. So nothing on the top is going to change. So x equals, so the first one we're going to have 4 pi. And then when you multiply by 3 on the bottom, you're going to have 3 times 3. So 4 pi over 9. 10 pi stays the same. 3 times 3 is 9. And 16 pi stays the same over 9. Do any of those simplify? It doesn't look like it. I think we're good on simplification here. All right, on to the second row. 5 pi stays the same, but 3 times 3 is 9. 11 pi stays the same, but 3 times 3 is 9. And 17 pi stays the same. And again, 3 times 3 is 9. None of those simplify either. So those are going to be our final answers. As always, if you have any more questions,